Good morning, everyone. Welcome to this Water Institute Water Talk. My name is Roy Brouwer. I'm the Executive Director of the Water Institute, and I'm joining you here today from home, like all of you, I guess. I'll be the moderator today, and I get help today from my Water Institute colleagues, Ellie Dusum, who's producing this Water Talk, and Nancy Goucher, who will help me to moderate the questions, the Q&A session after the Water Talk. Before we start, I want to acknowledge that we're participating today from traditional territories of the First People across the country. I'm here on the Haldimand Tract land that was promised to the Haudenosaunee of the Six Nations of the Grand River. And the Haldimand Tract is within the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. I would like to encourage you to take a moment to recognize the traditional land where you are. Before I introduce the speaker today, just a few housekeeping items. Please add your questions to the Q&A box, not the chat box, but the Q&A box, so that you can ask your questions to the speaker. You can do this at any time throughout the talk, and Nancy and I will then get back to your questions at the end of the Water Talk, and only use the chat box for general comments on technical issues. This webinar will be recorded and posted to the Water Institute's YouTube channel afterwards. At this point, I'm happy to introduce our speaker today, Professor Elena Bennett. You can see her on your screen. Dr. Bennett is Professor and Canada Research Chair in Sustainability Science at McGill University. Her work focuses on the interactions among ecosystem services and how we can manage these interactions for multifunctional working landscapes. Elena was the leader of the Montérégie connection that worked with stakeholders to understand the role of landscape connectivity in the provision of about a dozen ecosystem services and how those might change across a range of future scenarios. And she's currently the director of the NSERC ResNet, a strategic network designed to improve the monitoring, modeling, and managing of ecosystem services in working landscapes across Canada. Professor Bennett's most recent work focuses on using radical transformative experiments in society as seeds to improve storytelling and sense-making about how we might achieve a good Anthropocene. Today, her talk will be about the planetary boundaries to ecosystem services. Elena, we're very happy to have you here with us today. I'll hand over the floor to you.
Fantastic. Thanks for that lovely introduction. And I'm just going to share my screen here. Roy, you just confirmed you can see my slides. Great. So we'll just go ahead right in and get started. So I want to first thank you all for inviting me to come speak with you and for joining in from your homes or wherever you are to come listen. And so I would just want to start with just a little reminder, because this talk is designed around how do we think about the Anthropocene and how do we manage in the Anthropocene. And so what you are seeing here is starting on the bottom with the longest ago. You're seeing different epochs listed on the right, reaching our way up to the current official epoch, the Holocene. And what I'm suggesting is that we have something like an Anthropocene there at the top, not an official epoch, but a useful term that we might use to acknowledge human impact on the planet. So when we think about what it means to live in the Anthropocene, I find it useful to look first at, well, what does it mean to live in the Holocene, in the official epoch that we're in? And so this graph shows essentially the living conditions on Earth over the last 100,000 years through, in the blue line, a proxy for global temperature. And so that's 100,000 years. That's about half the span of time that modern humans, so people with the same mental and physical capacities that we have been on Earth. And so what you're seeing is basically that the global average temperature, that blue line, bounces around a lot. And that bouncing causes reactions in human existence. So we have a climate crisis, and humans leave Africa about 80,000 years ago. We have another climate crisis, another low bounce, and we colonize Australia. And all of those movements are in part driven by these temperature crises. And then about 10,000 years ago, so right there, we enter the Holocene, which turns out to be this remarkably stable period of of temperature. And about 1,000 years into that, we develop agriculture. And from that comes basically everything else that we learned in all of our history classes about human civilization, the Greeks, the Romans, literally everything else. And that's the only period that we know of, the only state of the planet that can support the sort of contemporary societies that we've built. And of course, we know that what's happening now is, we can't see it, but that little blue line is headed right on up out of this Holocene into what I would call the Anthropocene. And that's worrisome for a number of reasons, a primary one of which is that we don't really understand what the outcome will be, because the climate system is one with thresholds. So we often assume that systems are going to work like the image that you see on the left. So a given amount of change in the external condition leads to a consistent amount of change in the state of the ecosystem. But what the climate system works like is a more complex system with thresholds like the one on the right. And so, we might be heading along and we're changing the external condition a little bit by a little bit. And for a while, that's giving us a consistent and small change in the ecosystem state until we reach this threshold. And now just a small change to the right here, a small change in the external condition leads to a rather large change in the state of our ecosystem. And so it turns out that climate is just one of 9 systems that Johan Rockström and Will Steffen and their colleagues determined have global thresholds that threaten planetary stability. And they identified recently and then quantified the numerical location, I guess, of 9 different planetary boundaries. And that's the red circular line that you're seeing here. That's the location of these boundaries quantitatively. And then they quantified the state of the planet relative to those boundaries. And that's the length of these petals, where green means that we're still in an okay state. Yellow here for climate change means that we're headed towards that boundary. And these red indicate that we have passed the boundary for diversity, for certain biogeochemical flows. And if we cross those boundaries, we anticipate threshold responses in planetary systems. And so this is quite worrisome. And a lot of my work and what I'll talk about today is sort of how do we take this understanding, this concern that we have about crossing planetary boundaries, and use that to think about how we might assess the state of the planet and how we might actually manage it, because these planetary boundaries are great for assessing where we're at, but they don't necessarily tell us how to get back below those biogeochemical flow boundaries, for example. So I'm going to talk quite a bit about needing integrated measures for assessing progress towards a more sustainable world. And I'm going to focus in on a more sustainable Canada. And it's kind of amazing to me that even though we have pretty good measures for one indicator or another, we know a lot about, for example, food and food production. We know a lot about biogeochemical flows. We don't yet have anything that works as a sort of complete, integrated, generalized way to measure progress toward sustainability. So when I think about Canada, I think about a country that is incredibly rich, and especially incredibly rich in its diversity. So it's diversity of people and cultures and values, and its diversity in natural resources. And we see that echoed very strongly if we look at our economy. So here in color, you're seeing the net exports, and in black and white, the net imports. And what you should see is that this is an economy that is strongly rooted in resource extraction. So energy, mining, forestry, agriculture, metal ores. these things make up a substantial part of our national exports and a substantial part of our economy. They're very important to us as a country. So luckily, Canada is on a path that has acknowledged the importance of the environment, even as we know of the importance of resource extraction. And so we see plans like this one called Achieving a Sustainable Future. These are really plans like the recent plans that have come out for a new green economy, or how we build back better from COVID. And these things are unfolding federally, as well as in provinces and territories, even in cities and towns. And these are important as a sort of vision for where we want to go as a country, as a town, as a province. But we don't actually know very well how to assess whether we're making progress, because as you can see here, we tend to take each piece of this on separately. So we have separate chapters here for climate change, a separate chapter for clean growth, a separate chapter for wildlife populations, a separate plan for how we're going to manage land and forest, even though we know that these things interact. And we do that because that has been a way traditionally for us to simplify and approach this in a way where we can develop at least some indicators. So why do we need integrated measures? Let me just step back for a minute and make the case for this in two ways. So let's say for start that we're trying to assess the state of this landscape. So we might measure the amount of food, canola or barley or whatever is being produced on this landscape. And that would be a pretty good measure of one aspect of the value of an agricultural landscape in Canada. But it might be a little bit deceptive if we aren't accounting for maybe changes in farming practices. Maybe there's new technologies or better fertilizers or more fertilizers that are being used to increase production. And so if we only measured the food production, we wouldn't be getting a complete picture of what's going on. And similarly, those new technologies, maybe it's a different kind of plowing or additional fertilizers, those might have impacts on soil quality and health or water quality. And if we aren't also measuring soil and water quality, then we're also not getting a complete picture of what's going on in this landscape. And another reason why we need more integrated measure is that places are interacting. So in addition to these benefits like food and water quality interacting, we also see that places interact. So I'm showing here region A, B, and C, and those are depicted by the ball that's traveling through time towards us across this landscape. And there's little dips in the surface, and that make the ball more likely to roll into one place or another. And then there are different drivers down here underneath that are pulling on that surface, making it more likely for the ball to roll into one place or another. Those might be policies or social movements or biophysical things. And then of course, regions are interacting, and all together that is going to change how Canada travels towards a more sustainable future. So we need to be thinking about interaction of different benefits from the landscape, and also interaction of different places on our landscape. And so we can't do this piecemeal, even though we know that we do. So when I think about what I'll call working landscapes, so that's the landscapes that produce those benefits that I showed earlier that are important for the economy. So you might think about landscapes dominated by forestry or agriculture, energy development, mining, fisheries, etc. And in these landscapes, our focus has really been on cheap and efficient production of an individual benefit or ecosystem service, like timber in this case, ignoring the effects on other services or on other places. And we make decisions even though we have good evidence that there are interactions between sectors and across locations and among services. And that has really led us to a situation where we're making these really important decisions about the future of Canada and Canadian resources in a way that is more isolated and more piecemeal than we really want, and with a sort of, I would argue, limited picture of the ecological and economic and even social risks that are associated with those decisions. So I've spent the last 10, maybe now 15 years or so trying to work out what kind of scientific and other information is needed to help improve decision-making about ecosystem services in an integrated way. And what I'll do today is talk about a few projects, a sort of mix of empirical work and models that's complete, and then a little bit about my new network that's just getting started that aims to get us a little bit further down this road. And so this started for me really trying to think about cross-sector or cross-service interaction, and thinking about the fact that if we want to manage these interactions, we really have to know what's going on when we see service interaction. So if I start down here in this bottom right corner, we can see that in some cases we get ecosystem services that appear to interact because they're responding to the same driver. So fertilizer use increases crop yield and fertilizer use decreases water quality. And that's not to say that crop yield in and of itself changes anything about water quality. It's just that they're both responding to fertilizer use. And those should be easier for us to disentangle by changing management, for example, versus something like up here in the top left, where we have a strong interaction, but one that's not driven by the same driver. So here we might think about conservation tillage, which increases erosion control, keeps more of the soil on the landscape. That improves crop yield, which in turn feeds back to improve erosion control even more. So crop yield in and of itself isn't responding to conservation tillage, but it's responding to the erosion control. And so in thinking about that, I really wanted to investigate whether we actually see these different types of interactions on a real landscape, and decided to explore these in the area where I had at the time just moved, the area just outside of Montreal. And this was a really interesting place because one of the things that was going on was that the communities had agreed to put 17% of the land in each municipality into permanent green space. But they hadn't really talked about what that meant or what areas they were going to preserve. And so there was a great potential to sort of provide some scientific information that might help them make better decisions about which green spaces were more important to keep green, which they might restore, and which were okay to allow development on. So we went to the community and asked them about the benefits or ecosystem services, or now sometimes called nature's contributions to people, that they were seeing on the landscape. And this was a great way for us to start thinking about the multiple benefits that people are receiving. And we'd get answers like food or wood or maple syrup. And if we push a little bit more, we hear about things like pest regulation and water quality and carbon storage. And if we push more, we hear about things like aesthetic beauty and nature appreciation and deer hunting. And what we wanted to do was find a way to assess all of these across the landscape and their interactions. So that's exactly what we do. And so here again, you're seeing this petal diagram, and the petals, the length of the petal tells us how much of each of those services is provided on the landscape. And so we had some ideas about what that might look like. So for example, we might have a landscape that looks like this, where we have a lot of forest recreation, but maybe not so much agricultural production. Or a landscape like this with a lot of agricultural production, but not much forest recreation, or a landscape like this with a mixture of both. And what we were interested in knowing was how those petals are connected to one another. So for example, if I pull on and elongate that forest recreation petal, does that necessarily mean that my crop production petal is going to get shortened and vice versa? Or are there ways to change these petals independent of one another? So Kira Rautzep-Hearn developed this methodology to quantify interactions among services across a landscape. She looked at the dozen or so ecosystem services that I've showed you already. So the red ones are what we call provisioning. Those are the things. The green ones are regulating services. That's regulation of climate or nutrient runoff. And the purple ones here are cultural, like tourism and hunting and forest recreation. And it turns out if you measure the provision across the landscape, so here in darker colors where a service is provided, more of the service is provided, in lighter colors less, that every service has its own independent map of how it's provided across the landscape. And we do see some important correlations among those services, both synergies where we get more of two services together and trade-offs. And the trade-offs happen largely around, not surprisingly, around crops and pork that trade off with water, as we know, but also with deer hunting and carbon sequestration. And where we get synergies is in these regulating services and cultural services. So we get those sort of all coming together. So the next thing that we did was Kate Liss built for us a theoretical structural model that tried to identify the pathways by which landscape metrics, so now we're thinking not just about the land use, but about how it's configured, because remember what our users wanted to know was how can they change the connectivity or the location of green space on the landscape, and how is that going to impact ecosystem services. Built this model and then applied Kira's data to it to learn about this. And what she finds is that configuration, here shown in blue, matters. So yes, of course it matters what the actual composition of the land use is. So it matters whether your land is in agriculture or urban development or forestry, but where the land use is located matters almost as much as composition does. So there's an important role to be thinking about where on the landscape we're putting our green space, not just that it's 17%, but really where on the landscape we're putting it. We've then moved from there into mapping these ecosystem services at a much finer scale. So now we have built maps, thanks to Jesse Reeb, at a 30-meter spatial resolution, just smaller than most landscape patches. And we were able to do that without relying on land cover as an input. So Jesse was able to map, for example, agricultural production, high in green and low in red. He mapped at a very fine scale where deer hunting is on this landscape, what the carbon storage looks like on this landscape. And then he moved on to identify different classes of landscape configuration, so different sort of structures of what the landscape looks like, using a land use land cover map, a highly accurate one from our region. And what Jesse did was to take every pixel in this landscape and map it along where it sits in terms of three different landscape metrics: diversity, so the number of different land use types; the connectivity, so how close is that patch to a patch of a similar land use type? If it's forest, how close is it to another forest? And the distance to the edge of that forest type. And those are three that we know are meaningful for the provision of services. And when we plot those, the pixels in our study area fall on this sort of four-cornered polyhedron that you see here. And so the next thing we did was say, okay, well, we've got four extremes. We have one that is really represented by patch centers that are in very connected landscapes. We have patch edges in connected landscapes. We have fragmented landscapes that are low diversity and fragmented landscapes that are high diversity. And we can map those on the landscape so that we know where each of these patches is. So for example, here's number 2, my patch, I have these backwards, but this one is patch centers in connected landscapes, and that's in this light blue. And so you can see where we get more pixels that look like that. And then we're able to map the interactions. So this is a little bit complicated. Let me walk through what you're looking at. So first of all, the red arrows are trade-offs and the green arrows are synergies. And the width of the arrow tells you something about the strength of the interaction that's happening. And these are for each of the different ecosystem services that Jesse was able to map. And so then the panels, let me talk about those. So this is just the raw ecosystem service provision here at either 30 meters or 1 kilometer on the left-hand side. And then on the right-hand side, what we are showing is the deviation from what would be expected based on land use, land cover alone on the right-hand side, again at 30 meters and at 1 kilometer scales. So what do I want you to take from this? Mostly the raw data show roughly the same synergies and trade-offs that have been found in other earlier studies. And so that tells us that a lot of the observed ecosystem service interactions are pretty robust, especially differences to robust to differences in scale and differences in interactions and indicators. But if we look over here at panels B and D, which is accounting for land use, we see some interesting things that happen. So for example, for raw provision, we have a trade-off expected between agriculture and water quality. That holds true at both scales. But when we look at the deviation from expected based on land use, we see something changes here. After accounting for land use, we don't have that interaction any longer between agriculture and water quality. And now we can use that then maybe to look at whether this is changes in management that are affecting this. We're also able to look at how interactions between pairs of services change with landscape configuration. So if I show you here for deer hunting and maple syrup, so 0 means no interaction. Here's my landscape types across the top here. And this interaction between deer hunting and maple syrup is a trade-off overall across the landscape, but it actually has a synergy in our highly connected landscapes and only a trade-off in our fragmented landscapes. So we can start to look at how the configuration on the landscape impacts not only individual services, but actually impacts the interaction between pairs of services. We were able to look at these services through time too. Delphine Renard looked at the changes going back to the 1970s in a subset of the ecosystem services that we were interested in, and had a few interesting things that she found. So this is a map by municipality, starting in 1971 and going to 2006. And I think the main thing to note here is that where every municipality used to provide a sort of multifunctional mix of services, as we move through time, what we see is that overall the landscape provides the same services, but individual municipalities become more specialized, focusing in on one or a particular or two particular services. And we also do get some changes in synergies and trade-offs as we move through time. So we know that those things can shift. We went from there to working with Sylvestre Delmotte and our stakeholders in the region to develop scenarios. So they built a set of stories about what the future might be for this region, not meant to be predictions, but just a sense of the landscape might look like this, where we have a lot of demographic growth and infrastructure change that lead to some urban sprawl. And transformation of green space into housing and big box stores. Or the landscape might look like this one, where we imagined that a newly elected government would move towards wind and solar energy, towards electric cars, biomethane production, and a strong focus on landscape connectivity that you can see in all those hedgerows. And what we're doing now is using the data that we have, the historical data and all the 30-meter scale data, and these scenarios to try to build models and predict the service provision under those and other scenarios. I'm going to skip through that. So I want to get to the next part. So we're using that as a sort of pilot. But one of the questions that I was really interested in is what happens when we try to scale that up to the whole country. So I talked about this before, this recently released Federal Sustainable Development Strategy, or Achieving a Sustainable Future. And that lays out our priorities, but in this sort of disaggregated way where different landscapes and different sectors have their own focus and their own plans without necessarily thinking about how those are going to interact across sectors and across locations. And really looking at that and being concerned about that led me to try to develop this network called NSERC ResNet. And this network has a few objectives. So one is to try to improve our modeling of ecosystem services so that we can build better decision support tools. And then ultimately to use those two things to develop multi-scalar monitoring systems for ecosystem services. And so I want to use just the next 10 minutes to walk through a little bit about what this project is doing. We just got started about a year ago. In fact, our kickoff, reminder that this was a year ago, popped up of our kickoff. Ironically, we decided we would have an online kickoff in November to try to reduce travel, not knowing that reduction in travel was coming our way, whether we wanted it or not. So this network is made up of 6 different landscapes stretching across Canada from east to west, south to reasonably north. And each one sort of features a working landscape, agriculture or energy development or fisheries, that is facing a critical management dilemma. So if I just introduce you to one of those in the Bay of Fundy, so on the East Coast, led by Kate Sharon and by Jeremy Lundholm. This is a situation where the landscape is marked by dikelands that have been around for hundreds of years. And those dikes keep seawater out and allow for agriculture behind them. And they were really put in place by some of the first French settlers, the Acadians, and done with the French and the local Micmac tribes, who often helped with dike construction in the area. And a lot of those have been expanded, replacing about 80% of the bay's salt marshes. But today there are about 240 kilometers of dikes, and they really can't withstand the expected sea level rise and storm surges, and the Provincial Department of Agriculture that is responsible for them is saying they can't afford to maintain all of them. And so the question here, again, a spatial one, is about which should be maintained and which might be divested from? And how do we balance the ecosystem services that are associated with those dikelands, like biking and hunting and flood control, with those associated with salt marshes, like flood attenuation, when all the salt marshes can't be maintained. And so like what I showed you in the Montérégie, the area outside of Montreal, each of these landscapes is working to map land use, to map ecosystem services, to understand the human and social networks and other factors that drive the provision of ecosystem services in their landscape, ultimately resulting in measurement of provision of services across these landscapes. And each is a little bit different, but we have 5 ecosystem services in common across all of the landscapes. And we have a set of themes that are integrating across services. Let me go back. The landscapes are integrating across services and sectors. And what the themes are doing is helping us to integrate across places and understand a little bit better about how we can synthesize across what's happening in different locations. And finally, there's a synthesis team that's responsible for ensuring synthesis across the themes as well, sort of closing the loop by ensuring that we're also integrating with our partners, policymakers and decision makers at every scale, from the landscape all the way up to our national scale partners. We're very much following the plan that we set out in the Montérégie, with a series of workshops, working with our stakeholders, interspersed with getting out into the field. I want to talk a little bit about the people who are engaged just very quickly. We have a great leadership team of leaders in every landscape and every theme, a 17-person leadership team with predominantly female leadership, a really strong, very multidisciplinary group. And I was really excited to have this group putting together this proposal. And I'm even more excited now. So we got started about a year ago. We now have about 50 or maybe even a little more new students and postdocs and collaborators and partners who are really driving things forward. So in just a year, had quite a lot of growth in the scientific team. And an equally committed and really ideal set of partners. So we have partners in every landscape. Some of those are scientific partners helping to drive the science forward. Some of them are what I would call user partners, who are interested in the information and outcomes of the science that we're developing. And a number of federal partners as well, who are, again, either science partners helping build models that we can use to understand our working landscapes all across Canada, or outcome partners who are interested in the outcomes that we come up with. And all of this building together to help us put together what we've been calling an ecosystem service observatory network for Canada. So in other words, what would you need to measure if you wanted to answer the question that I set out at the very beginning about understanding in a more integrated way across locations, across sectors, across ecosystem services? If you wanted to understand what's happening in Canada, are we moving towards the sustainable future that we want to achieve or not? What would you need to measure, and how would you need to measure it? And our ultimate goal here is to build towards that ecosystem service observatory network of Canada. So I'll just say thank you for listening, and maybe check back in. We just started this year, so check back in 5 years or so, and we'll see where we get to, whether we've gotten to our ecosystem service observatory network of Canada. So thanks so much for listening, and I'll turn it back to Professor Brouwer to help manage the questions here.
Thank you very much, Elena. Normally you would hear an overwhelming amount of applause after your excellent presentation. Thank you so much for sharing this fantastic cutting edge research that you're doing with your group in Montreal. I actually remember 1.5 years ago to be part of that review committee of your NSERC strategic partnership, and it impressed everyone so much that you managed to bring all these different partners around Canada from all these different disciplines together in this amazing network. I'm very happy to hear that it has started, that it's already 1 year into the project lifetime. I'm going to give Nancy some time to look at the Q&A box. I see we have a few questions. I'll just start off the discussion by asking you some initial questions, and then I'll hand over to Nancy and the audience. I was wondering a little bit, I think it was around 2009, Gretchen Daly and Steve Polaski and some others wrote this article about ecosystem services and time to deliver. And just as a kickoff, how do you see the current policy landscape respond to these kind of initiatives, your initiative? Is there really integration of the concept of ecosystem services in policy and decision making, maybe especially in spatial environmental planning or urban planning?
That's a great question. Yeah, so that paper, that 2009 paper that Gretchen led has really been an inspiration for me. So I think she was sort of getting at this idea that we've been talking about this a lot, but it's not really getting integrated or used. And I think it's a mix now. I think there's a lot of interest in using ecosystem services, but still some confusion about how to use it exactly, or what to measure, or how this can be useful. Although we're building, and I think ResNet has a place to build here by involving these decision makers in the sort of process of developing the indicators. That's often a way that we see that helps people get over this boundary of, oh, I don't know what that is and I don't know how to use it. I do think we're a little bit hampered still in really taking this on simply by the structure of the way we're set up to manage resources in Canada. So we have, separate provincial entities that are doing a lot of the resource management. Then we have a federal agency that is responsible for environment, a different federal agency that's responsible for statistics and measuring, a different federal agency that's responsible for agriculture. And so we're set up in a way that makes it very difficult to cross those boundaries, although we're seeing it happen. We have partners from all of those groups in ResNet, and there's other groups who are doing similar things. So I'm optimistic, but we need to be prepared for it to be slow, I think.
Yeah. I also wondered, so you look at synergies and trade-offs, and I think it's a very important step that you start with the mapping, the identification, the mapping. In the identification of the trade-offs, do you also do monetary valuation of synergies and trade-offs?
So I have not done so much of the monetary valuation. I know that others are. And part of the reason that I didn't was I had some early experience doing that. And what I found would happen was that there would then be a dollar value, and the dollar value would really clearly point to, well, this is worth $1 million and this is worth $500,000. And then everyone would assume that that was the right direction, even if it didn't necessarily reflect everyone else's values about what people really wanted. So I found it a little bit more useful, although a lot more time consuming, to present, actual biophysical measures of services and then lead the community in a discussion about what they want. Although I think there is also definitely a place for that monetary valuation that adds a lot more information to the table in terms of what the communities are considering.
Thank you. Nancy, can I hand over to you?
Certainly, thanks. So first, you should know that there's some praise here. People loved your talk. People loved the slides. They were beautiful. So that's important to note. There's one quick question. What's ways to follow along with progress? What's the best way? So maybe it's LinkedIn or Twitter, or how are you sharing some of the progress that you're coming up with along the project?
Yeah, so that's a great question. So for NSERC ResNet, we have a website. It's just ncircresnet.ca. And that's a great place to go to. And we're in the process of trying to develop a public-facing newsletter so that people could sign up for that newsletter and hear a little bit more about what's happening. You can imagine with the pandemic, it has been more complicated to start during a pandemic when the 17 people that I showed you as the leaders all know each other from being at the site visit with Professor Brower, but the other 60 people don't know each other. So it's been complicated. So I would say that, and then we also have a NSERC ResNet Twitter account. That would be another place to follow along with little updates. But have a look at the website as a place to start and stay tuned for an outward-facing newsletter.
I take the next question, Nancy. So maybe a little bit related to the question that I asked you about Gretchen Daly. One of our participants is asking if you could identify some of the major barriers that inhibit the increased application of these ecosystem services approaches in spatial and land use planning.
Yeah, okay. Another good question. I mean, I think one of the barriers, remarkably, is simply information. You know, you could see some of the early data that I was presenting were from 2009 in the area outside of Montreal. And we still have not progressed that far in most places in terms of just having data that is comparable on ecosystem services in particular locations. So I think that's a start, is just sort of getting the information that we need especially in a usable format. It's why we're thinking about this ESON-C as being a sort of dashboard where a policymaker or user could go in, adjust different sliders, really look at things to understand services. So I think is one big barrier that we're seeing now.
There's also a question about how do you quantify values? So it's maybe a little bit related to the economic valuation. Does every person's or ecosystem's value count equally?
So it's a great question. It's something I happen to be really excited about right now because folks have been talking about, like, you know, okay, we measure the provision of this service, but how do we know whether people benefit from the service? And when we can sort of assume, but, you know, if I take food production in the area outside of Montreal, that food production isn't really going to local people to eat. A lot of it is, in fact, growing pigs that are being shipped to China for people there to eat. So there's an economic benefit here, but not a food benefit. And so what we've been building a proposal actually to do interviews in different landscapes with our stakeholders so that we could ask questions about what benefits they're receiving from these services and how they value those, and to do that stakeholder group by stakeholder group. So a lot of our ResNet landscapes, for example, have very strong First Nations partners. And so we'd really like to know how values from that group might be different from values from settler groups, for example. And I think where we've landed so far is that the way to do that is through stakeholder interaction and social network mapping and interviews. So stay tuned.
Mm-hmm. Thank you. I think Nancy's going to take the next question.
Yep, this is from Dr. Nandita Basu. She loves the idea of the trade-offs and how the spatial structure of landscape impacts the trade-offs. Here in Ontario, we're having discussions about whether a partially degraded wetland in an urban area provides the same service or a lower service compared to a wetland in, say, Algonquin Park. Do you have any thoughts on this complicated question of wetlands?
Yeah, so that is a complicated question. And we've been talking about this a little bit in my lab group. It's sort of along the lines of if a tree falls in the woods and no one's there to hear it, does it make a noise? And I say that because you could, of course, measure the function of that wetland in the urban area and the function of the wetland in Algonquin Park. So you could look at, nutrient retentions, let's take as one particular service. And so we could pretty easily measure that and know the difference in that function. But of course, that doesn't necessarily tell us the value or the importance. So if your wetland in Algonquin Park is surrounded by other wetlands that are performing more or less the same function, maybe it's less needed than the solitary wetland in an urban area that is, the only place around providing that service. So there's a very there's sort of an art as much as a science to this, where I think it really behooves us to bring in economists and social scientists and other partners who can help us to assess, at least for me as a natural scientist, who can help me to understand the other side of that story that isn't just, well, there's, X amount of nutrient kilograms per hectare is being trapped, but also what's needed and by whom and who's benefiting and so on.
Great.
Nancy, there is a question in the chat from Anita Lazurko. Shall I just read that one?
Sure, go ahead.
So Anita's asking Elena about the link between your work on ecosystem services and the need for transformative change to achieve this sustainable future for Canada that you were referring to in the beginning. So for example, your work on Seeds of Good Anthropocene has inspired transformative scenario methods where promising initiatives are imagined as mainstream. What opportunities do you see for us to use these creative methods to explore and inspire more transformative changes to achieve a sustainable Canada?
Y'all are not asking the simple questions today.
No,
which is great. It's nice, one of I love Zoom because we can get more people, but you sometimes lose some of the interaction, but it's the complicated questions are really nice for having that feeling of real interaction. So what I often say about, in my own mind at least, about the link between those projects that might on the surface look very different is that my Seeds of a Good Anthropocene and this sort of visioning, it's really important that we have a vision for where we want to go to in terms of transformations to a sustainable future. And that project has really, at least for me, sort of opened up an avenue for thinking about how we do that and developing rigorous methods for doing that sort of envisioning. But what it hasn't done, at least so far, is then point to any way to measure where are we along the pathway of getting to that future. And so that's where I think the ecosystem service piece comes in, is in helping us to give some quantitative measures or assessment in a way that, hopefully helps us to take the next steps that bring us closer to the transformational future that we want and not farther away. And that sounds like it should be simple, but actually I think this interaction across services and sectors and landscapes or locations really makes it very complicated to tell whether any one particular step is getting us closer to or farther away from the future that we want. So I think there's a pretty important role for both of those, both the visioning and the measuring.
So I think we have time for maybe one more question. Nancy, do you want to select one?
This is from Professor Susan Elliott. So with respect to quantifying values, can we link with the Canadian Index of Wellbeing, or maybe the data that's in the CANU database that addresses pan-Canadian links between environmental exposures and human health?
Yeah, so it's a great question and a really great idea. And we've just been starting to look into these well-being indices and sort of how we might make that connection, which is complicated a little bit by by spatial scale and the kind of information that's collected and how different things move. So money, like when I sell my Quebec pork, moves very easily between places, but recreation doesn't move so easily. I have to go to that spot to recreate there. And so we've been trying to dig in a little bit for how we connect these things that move and things that don't move in order to better be able to use some of those well-being indices and other databases. It's a great idea.
Okay, maybe we have time for one last question, and then I think we really have to wrap up. We have really a lot in the Q&A. The last question I would like to ask you is on behalf of an anonymous attendee. Does taking your approach to the extreme eliminate the need for human decision-making in planning? Could it fully automate land use planning? What will remain for us to decide is the question.
I don't think so. It's an interesting thought exercise, but I think we still need people to come in and say what they want and how they're benefiting from the landscape. Even if we have this data, it doesn't necessarily tell us whether we need the wetland or the timber. That's really about human values. So I think that there's still a role for people there, even if we have more data.
Thank you. So I'm afraid we have to stop here. Dr. Elena Bennett, thank you so much for participating in this WaterTalk this morning. That was a great presentation of the work that you're doing. Very impressive, very multidisciplinary, exactly what we like in the Water Institute. I also want to thank our audience here today. This was the last WaterTalk of the year, of the term and the year. And I look forward to see you again half of January, on the 14th of January, when we will start the WaterTalk series again. And we will have Wendy Graham, the director of the Water Institute at the University of Florida, with us. So stay healthy, stay safe, and happy holidays if I don't speak to you again. Thank you all very much for participating.